In proof number 1, you are told that A is parallel to B, so these two are parallel, and you're told that C is parallel to D. So what that's telling you is that you can use any of those 5 different angle relationships, the alternates, the consecutives, the correspondings, using these 2 lines. So all of those angle measurements are going to be true for A and B and for C and D. So we somehow need to state that angle 1 is the same as angle 3. They don't have any direct connection right now, so we somehow need to connect 1 to 3. So hopefully at some point along the way you're thinking possibly we would be using transitive. So our givens are that A is parallel to B and C is parallel to D. Again, you can write those in 1 step or in 2. If we need to eventually connect 1 to 3, we first need to get 1 and use 2. In a diagram, if they give you angle 2, they're not just showing you that for no reason. It's something you're going to have to use. So hopefully you realize that angle 1 is congruent to angle 2, and that is because they are corresponding. Now again, we still need to try to get 3 involved. So again, we don't know 1 and 3, what their connection is, but we do know that 2 and 3 are also congruent. So angle 2 is congruent to angle 3. That's also by corresponding angles. And our very last step is to say angle 1 is congruent to angle 3. And hopefully at this point you realize that is where we will use the transitive property. Because if 1 is congruent to 2, 2 is congruent to 3, then we know 1 is congruent to 3. On a proof like this, it really helps to think, before you even start writing steps, think, how would I even know that 1's congruent to 3? And maybe you'll come up with the idea that 1's congruent to 2 and 2's congruent to 3. So you know that those are the steps you're going to have to follow in your proof.